So I'm guessing this is all of you. So if you have any question, you can stop me on the way, right? So I'm gonna start. So for today, we are going to do, we are going to do utilities and portfolio choices. So so in utility, so this chapter, it's actually quite long, but then when you practice it, it's not like the concepts are not that difficult. It's just that it has like very long proofs. So I'm gonna start. So we're gonna start by explaining what is utility. So I won't spend a lot of time on the first section, but then I'm gonna spend more time explaining explaining again, I'm like portfolio choices and those other things, because they are the one that most of you have said you have a problem with. So in essence, utility is basically just the satisfaction you get from taking a particular action, right? So when you are an investor, so what is your utility? So your utility will depend on the amount of wealth that a certain that a certain investment will have. So we are going to explain more about so these options. So let's say maybe you let's say maybe you have two options, X and Y. So when you have X and Y, what can we say about your utility? So you have two investment options, X and Y. We say that X gives you a higher, we say that you will choose X if you will choose X if if the if the utility of X is gonna be greater than the utility of Y, and then you are going to choose Y if the if the utility function of Y is gonna be greater than that one of X, and then you are going to be indifferent between these two, indifferent. If they have the same utility, so they basically give you the same satisfaction. So again, so this is what we call consumer preference. It's possible that someone can choose X over U, and then someone else can choose Y over X, and someone can be indifferent. That happens because we have different utility functions. So when one person view X as a good investment, that will give them a higher satisfaction. Someone else can look at Y and say this one is going to be a better investment because this is going to give me a higher satisfaction. So all this comes back to consumer preference. So before we continue, we need to learn a little bit about the theorem, which is called expected utility theorem. So the expected utility theorem states that a function of a function of utility can be constructed preparing an investor's utility of wealth at some future time. So it's possible to make a function of utility by looking at the future outcome of that investment utility. So it is possible to find the expected utility of an investor, looking at what that investment is expected to yield. So if an investment, let's say maybe you have investment X, right? So this investment has a price, right? And then it has payout. Let's say maybe there are two things, I'm like there are two outcomes that can happen. Let's say if the economy is bad, or let's say good, or if the economy is bad. Good and bad. So here, let's say you're gonna have a payout of 100. Here you're gonna have a payout of, let's say, 50, right? So these things are expected because they have probability. Like this thing can happen with probabilities 0.3. Let's say maybe this one can happen with probabilities 0.7. So what this theorem says is that we are able to find what is the expected satisfaction of an investor by just looking at what again, I'm like what the payouts will be of that asset. And since we don't know the future, but then we can speculate on like what is the probability of a future outcome happening. So we are able to find the expected utility. And to find this expected again, I'm like this expected utility, you're just gonna find is the expectation of utility in terms of wealth, right? So the answer will depend on whether it's discrete or continuous. And if it's continuous, you are going to say the utility of, so this is the utility function u of x times f dw, negative infinity to infinity, and then the sum. So this one is for continuous, this one is for continuous, then this one, the sum for all i's, again the utility in terms of wealth times the price, right? Again the payout, I'm like the probability, sorry. So this is gonna be your probability, and this is gonna be your probability density function. So yeah, and then you can find the expected utility. So basically this is it in terms of like understanding the expected utility of an investor. So obviously when we are trying to find this decision, we are trying to maximize the expected utility. So when we have to choose an investment option for an investor, we will have to choose the one that yield maximum, which will yield a maximum utility. So I'm gonna move on. So there is axioms of utilities, so I'm not gonna talk much about them. I'm gonna talk about this one later on, but then I think that you can read the rest in your book. So again, I'm like from your notes as well. I don't think they are that complicated, but I'm gonna explain this one later. So before we can continue, right, so I have a question for you guys. So I want you guys to answer this question. So you can unmute your mic or you can write it down. So if you have two options between option 1 and option 2, option 1 I just give you 10 rand, and then option 2 I ask you to toss a coin, and then if the coin land on head, I give you nothing, and then if it land on tail, I'm like, yeah, I give you 20 rand. So which option would you choose? choose one. So which option would you guys choose? Okay, Nicole says she will choose option 1 because it's safer. Anyone else? Okay, Chad as well, like he's gonna choose option 1. Is there anyone who will choose option 2? Okay, I assume there's no one who will choose option 2. So again, these two options, right? These two things, they have the again, sorry. So they have the same expected return, average. So this one, like you have average. So this one you have one again. So for option 1, you are going to get 10 rand with absolute certainty. So the average is gonna be 10. So this one as well, you will either get 0 rand or 50 rand again, or 20 rand. The average is gonna be what? It's gonna be 0 times 0.5. We assume the coin is unbiased times 0.5. So even this one has the same expected return, right? So I want you guys to like keep these options in your mind as we are going to again as we are going to learn more about characteristics of characteristics of utilities, because they will tell us what kind of an investor do we have. So there are multiple kind or types of utility. Characteristics of utility. Number 1 is the principle of non-saturation. They say that the principle of non-saturation means that you prefer more to less. That is, you prefer more to less. So, and they also say that the utility function of this, so let's just say it's x, is going to be increasing. So what does this even mean? What this means is that every time your wealth increases, you are going to be more happy than your previous wealth. So when your wealth increases, you get more happier. So I'm going to show you by one of the graph. So let's say maybe this is your utility function, and this is your wealth, and this is your utility in terms of wealth. And let's say maybe this is your utility function. So this graph shows principle of non-saturation, because when your thing increases, okay, this pen is not working. When your wealth increase, you get even higher satisfaction, and as it increases further, you get even higher satisfaction. So this is what we mean by the principle of non-saturation. It does not only apply to this curve alone. You can look at some other curve. Again, you can say this one. Again, as your wealth increase, this is wealth. As your wealth increase, so does your satisfaction increase. Like as your wealth increase, so does your satisfaction. So again, this is called the principle of non-saturation. Even if your utility function is like this, it's a straight line. At the end of the time, I mean, like, again, at the end of the day, as your wealth increase, so does your satisfaction. So this is known as the principle of non-saturation. So when we add more wealth, or when we so when your expected return of your portfolio increases, or your expected payout increases, or when your wealth increases, so we expect your happiness to also increase, right? So this is just the principle of non-saturation. So another thing, so characteristic number 2 is called risk averse. So we say that someone who is risk averse will reject a fair gamble, and their so their utility function is gonna be like this. So you're gonna say the second derivative is gonna be less than 0. So okay, I will explain shortly what I mean by you will reject a fair gamble. So I'm gonna go to the third characteristics, and then I say that here you are risk seeking. So again, sorry, here I can also add that this thing is gonna be what, concave. So risk seeking, we say that the second derivative of your utility is gonna be increasing. So we say that you are convex, and we say that you are, again, you seek a fair gamble, right? So before, okay, and then the last one is when you have a point of inflation. It's when your second derivative of your utility is going to be 0. So this means that you are indifferent between a fair gamble. So what do I mean by a fair gamble? I'm going to give, so okay, so we're going to go back to our example, right? So we say that a person who is risk averse will reject a fair gamble. From these two options, you have option 1, you have option 2. So option 1 gives you 10 rand, right? And then option 2, you will either get 0 or 20 rand, both with probability of 0.5, meaning that the expected returns is going to be 10 rand and 10 rand, right? So option 2 is what we call a gamble. So option 2, it's a gamble, right? Because there is probability involved, right? So you can either get nothing or 20 rand. So option 1 is the one which is again, I can use the word safe, right? So if so you can see that at the end of the day they have the same average, like they have the same expected return, right? So we are going to call option 2 a fair gamble of option 1 because they have the same expected return. But a person who is risk averse, right, they are afraid of risk, right? As the name suggests, they are risk averse. They are going to reject this fair gamble. They will reject option 2. They will reject option 2 because they are afraid of the risk involved, right? As the name suggests, they are risk averse. Like they can both have the same expected return, but they are going to reject this option 2 because you can also lose. Like for them, again, what is most concerning is that is a probability of losing everything, right? So they would rather stick to the safe option as long as they both have the same expected return. So a person who is risk seeking will accept, they will seek option 2. They will seek option 2 in place of 1 because they love risk. So these two options have the same expected return, but then option 2 has a probability of having a higher return. Like it has a probability of having a higher return, and this is what gives them thrill, or this is what gives them this satisfaction. So we say that this person is risk seeking. They require this risk mostly because it also has a upside risk, right? So you can get a higher return from this investment. So this is what they mean by accepting a fair gamble or rejecting a fair gamble. I can show you these things in terms of graphs, right? So let's say this is gonna be point A and point B, right? So a gamble between point A and B is gonna be in here, right? But then this line just show an increase in wealth, right? So if you have to gamble between A and B, which is this line between A and which is this line between A and B, you can see that this person is better off just like sticking to the line than picking this gamble over here. They are better off staying here on the line than taking a gamble over here, because this one up here will give them a higher utility than option 2. So when your graph is concave, we say that you are risk averse. And then a person who has a convex utility like this, let's say maybe they have to choose between A, so they can either gamble between A and B, so which is this line, or like stick to their own generic wealth. As you can see, taking this gamble between A and B will give them a higher satisfaction than like sticking to their own normal utility curve as their wealth increases. So this person, we say, is risk seeking. So when your utility function is a straight line and you have to choose between A and B, that line, the gamble between A and B is just gonna be in between here. So you are therefore indifferent. So indifferent. So I say, I can just say indifferent. This is what they mean graphically. So anyway, I hope this makes sense. I'm gonna move on to measuring risk. So the question of what happens when your wealth increases, like, do you want to invest more in risky assets, or do you want to invest less in risky assets as your wealth increases, right? is answered by the absolute risk aversion. We answer this question using absolute risk aversion. So on absolute risk aversion, it's going to be negative the second derivative of this over the first derivative of your utility function, right? So if your absolute risk aversion increases, right? So if this thing is increasing, it simply means that the more you get wealthier, the more you are risk averse. Like it's in the name, right? Risk aversion. So it doesn't measure your risk appetite. It measures your risk aversion, like how risk averse are you as you get wealthier. So if your absolute risk aversion is increasing, so by the way, this thing is measured using Arrow-Pratt. So this function is called the Arrow-Pratt absolute risk coefficients. So when your risk aversion is increasing, we also expect that you so yeah, when your absolute risk aversion is increasing, it simply means that the more you get wealthier, the more you are risk averse. Like you would not want to put more of your money in risky assets. Actually, you would not want to put money in your risky assets. You would want to play it safe. So when your absolute risk aversion is decreasing, it simply means that when you get wealthier, the more you want to take risk because your risk aversion is decreasing. So these questions are all answered by the absolute risk aversion. So in terms of relative risk aversion, so this question is answered so using this coefficient negative x second derivative of your utility over the first derivative of your utility function, right? Okay, so when your relative risk aversion is increasing, it simply means that you become more risk averse, and then you are going to invest less of your proportion. So less of your proportion of wealth is gonna go towards your risky assets. And then if your relative risk aversion is decreasing, it simply means that you are becoming more risk seeking, and you are going to invest more proportion of your wealth in risky assets. I hope that makes sense. There's also a graph I can show you now. You can say absolute risk aversion. Can say increasing. So if you forget things, you can just basically use this function. I'm like this graph over here. So before we continue, we will have to do a couple of examples. Okay, it's one example actually. So this thing is already a memo. So this part here, it's an answer. We are mostly going to focus on this one over here. So anyway, this question says that an investor has the following utility. Okay, I think this thing is too bright. Okay, it's okay. Where this thing is gonna be greater than 0, where wolf is gonna be greater than 0 is a wolf, and a it's a real number, it's a constant. So show that a constraint exists on the value of a, over here, if she prefers more to less. So again, we say that if she prefers more to less, that is called non-saturation. And also when she is risk averse. So preferring more to less simply mean that your utility function is going to be greater than 0. And then if your utility function is going to be greater than 0, from here your first derivative is going to be greater than 0. That is a minus a w, that greater than 0. We can see that we know that this thing is always going to be positive, right? So therefore a is going to be greater than 0. So this is how they have arrived at this conclusion over here, right? So using the risk averse thing, it won't really give us much on this. Again, I'm like on this thing, because when you find when you find the second thing, okay, I'm gonna put this in a bracket. When you say that this thing, negative a squared e minus a w less than 0, like it does not give you any more constraint. So I can talk about another example so that it can become clear. So let's say maybe your utility function is w, and you have a ln of x, right? So this is your utility function. So if they ask you for the constraint over here, you using the same principles, non-saturation. So non-saturation, then we say that the first derivative is going to be greater than 0. So this simply means that a, so this is the first derivative, a over x greater than 0. It simply means that x is going to be less than a, right? So this is the first constraint. And then the other one, let's say maybe is risk averse. So if this person is risk averse, it simply means that the second derivative of the value is going to be less than 0. So this means that a, negative a over x squared is gonna be less than 0. This simply means that a is gonna be greater than 0. As you can see, now you have more constraint that x is gonna be less than a, and then a is gonna be greater than 0. So if you are tempted to say that when like x is not equals to 0, so don't be tempted, because okay, yeah, you can say this, that x is gonna so x should not be equals to 0, and x is gonna be less than a, and a is gonna be greater than 0. So if you have a function like this, then you will have more constraint, unlike this one over here. So anyway, we're gonna move on to question 2.
Hi Tabella, can I ask a question?
Yes.
How did you get x less than a? Shouldn't it just be a greater than 0?
Why on this one?
Yeah, the non-satiation one.
How did I get x
in the orange square?
How did I get x is oh sorry. Okay, I made a mistake. Sorry, I'm sorry. I'm very sorry. It's supposed to say a is greater than 0.
Okay, thank you. I thought so.
Yes, I'm sorry for that. So okay, it simply means that you have the same constraint in both ways. A is gonna be greater than 0. A is gonna be greater than 0. Okay, yeah. Thank you. Okay, I was trying to think of another example where you would have two constraints, but then I think it's fine. I think this is sufficient for now. So number 2, derive Hay absolute risk aversion and relative risk aversion. So absolute risk aversion this is in terms of Wolf, so we put Wolf over here. So this is the answer for this one. I hope I'm doing right. So did you get did you guys get the same answer? So do you guys get the same answer, or am I making mistakes somewhere? Okay, I will have to read from the comments. Oh, sorry, Honorable, I didn't see your question over there. So you say that, so do risk-seeking and risk-averse investors experience that situation? Yes, both risk-averse and risk-seeking individual as well. Yeah, as long as your utility function is increasing, then you are again you fall under non-saturation. So you can already see that this thing is gonna be constant. It's gonna be constant. This one is gonna increase because when you find a first derivative of that, it's gonna be equals to 0, therefore it's constant. And then when you have the first derivative of that, of the relative one, your answer is gonna be a which is greater than 0, therefore increasing. Okay, I guess this makes sense for now. I'm gonna move on. So the concept of certainty equivalence. If again we're gonna go back to the functions because graphs, because they are much easier to explain. If this is your utility function and you have option A and you have B, and you find the probability P, right? Let's say maybe you have again you have probability P such that again such that you have B times P plus 1 minus P times A. Let's say maybe this answer is gonna lie somewhere here. So we say that the certainty equivalent of this is gonna be this option here. So it's gonna be this point over here, right? So they both have different valve, so we can say this point is C, right? So we call this C the certainty equivalence. So basically finding the utility of C equaling to the expectation of the utility. So I think this will make more sense when I do more examples. So okay, we're gonna do this example over here. I forgot which paper it is from. So it says that in order to illustrate a complex investment decision problem, the following simplifying assumptions about utility and distribution function are used. X is a random income and U is the expected utility, which has this function. Let X be normally distributed with mu and variance sigma squared, right? So we are not gonna do this one. You can do it on your own. And say that what are the restrictions. As you can see, this one it's also similar to the one we did previously, because this one again, I'm like the one we did previously had just like it was 1 minus E minus Rx, so they are not that different, so you are going to have the same conclusion. So we are going to focus on 3.3. Assume that the expected utility is like this. Hopefully you can see. I'm gonna zoom in. So they say that show that C is the certainty equivalent of X. Remember that X is a random variable, right? X is a random income. So you are trying to find C. So what is the certainty equivalent C of a random variable X? So I said that the equation is going to be like this. So in this question, they already told you that the answer is this. So you will have to work from here to here. So this is what they are basically asking you. So to find the certainty equivalent, we say that the utility is going to be equals to C, the expectation of the utility in terms of X, which is a random variable, and then the utility function was negative E minus R X. So in place of X we put C, equals to the expectation of this. They have already given you there, so you are basically going to write negative E R squared sigma squared over 2 E negative sigma R, mu, sorry. You can basically write this as negative E R squared sigma squared over 2 minus mu R, negative E minus this, and then you will have negative RC equals to what? Equals to R squared sigma squared over 2 minus mu R, and C is going to be what? C is going to be mu minus R sigma squared over 2. So this is what they were asking you. So the answer are the same, so you have found it. So sometimes they may not even give you the answer. They will not tell you what C is equals to, so you will have to like figure it out on your own. So now we are going for our last part for insurance before we can go to portfolio choice, which most of you need help with mostly. So I'm not gonna spend again a lot of time here. So for insurance calculation, it will depend on whether you are an individual or you are an insurance company. So as an individual, you are basically trying to find P, where P is the maximum premium you are willing to pay, maximum for a random loss, for a random loss X, right? While your initial wealth is A, right? And then so the function for this is gonna be this. It's gonna be the utility A minus the premium, because it's what you are sure you are going to pay. Again, the expectation of the utility A minus x. So this is how you are going to calculate your p. So when you want to calculate how much your p should be, you basically use this function, like this formula or this equation, when you are looking for an individual. And then for a company or for an insurer, they are trying to find the minimum. So is the minimum they are willing to charge. So this minimum, I'm going to say it's going to be Q. So this minimum Q for a random loss Y, while they have initial wealth of A. So to find this answer, you say is the utility of A equals to the expectation of the utility of A plus Q minus Y. So yeah, so this is it for insurance. I can't find past papers which have insurance at the moment, but then if I do, I will send them to the group. So before I move on to our second lessons, where we will be focusing on portfolio choices, are you guys satisfied so far? Do you have any questions? I'm going to open the messages now. You can also unmute your mic. Okay, I assume there's no question. So we can take a 2 minutes break. At 2 o'clock, we can start. We can start with utility. Okay, we can start with portfolio choices. Is that fine?